Hello. So problem number 1563 stone game 5. So problem states that there are several stones arranged in a row and each stone has a stated value which is integer given in the array stone value. In each round of the game, Alice divide the rows into two non-empty rows, left row and right row, and Bob calculate the value of each row which is the sum of the value of all stone in the row. Bob throw away the row which has the maximum value and again an Alice score increases by the value of the remaining row. If the value of two rows are equal, Bob let Alice decide which row will be thrown away. Okay. The game ends when there is only one remaining stone. Alice's score is initially 0. Okay. So they have given one example 6, 2, 3, 4, 5, 5. So let's understand this problem. So, so what they have given? They had given 6, 2, and 3, 4, 5, 5. 3, 4, 5, 5. So there are two players, Alice and Bob. So what they are doing, they're playing a game in which Alice will always start first, then Bob, then Alice, and then Bob. Like, I mean, it will be like this. So Alice will divide this into two halves, not equal halves, but like two parts. Suppose Alice divides from here and here, and the sum of this part is 8, and sum of this part is, for example, 7, 5, 12, 5, 17. So Bob will throw away this part, and again Alice will get this part for its next division. So like here we can say that suppose this our example 6, 2, 3, 4, 5, 5. First Alice start. Suppose like she had divided something like here again. So this part is 8 and this part is 17. So what the Bob will do, it will take away this part and will throw it away. So now the Alice score will be something like 8. The smaller part will be given to the Alice, and also the part which has the less number of the sum. For example, like if we see here, the part which has less sum is 6 comma 2. So again this part will be given to Alice for further subdivision. So if we see here 6, 2, 3, 4, 4, 5. Now suppose Alice divides something from here. So 6 to 8, 15 and 4, 5, 9. Now what will happen? Now Bob will take away this part and will throw it away. Now again Alice will get this part only 4 comma 5, and the score which Alice will make 9. So like this we need to divide this. So at the end we need to keep on dividing, and when the one stone left then we need to stop, and like this we need to find the maximum what Alice can make. So if we see here for this problem 6 to 3, 4, 5, 5. So Alice can divide here. One option Alice has, like she can divide it here, and this part will be given to Bob. So this one part will be for Alice and this part will be for Bob. One option Alice had that she can divide it here also, and rest of will be like given to Bob. Third possibility will be like this. Alice can divide it here and rest of will be like given to Bob. I mean, we need to calculate. For example, here, if we say the sum of the left part is 6, and if we calculate the sum of the right part, 2, 3, 5, 4, 9, 5, 14, 5, 19. So Bob will take the highest sum part, will throw it away, and rest will be given to Alice for further play. So we can here see for Alice there are multiple possibilities, right? She can divide it here, she can divide it here, she can divide it here, she can here or here also. This is the last where she can divide, like in the first go. Now, if we see here, 6, 2, 3, 4, 5, 5. What Alice is doing? First, she is splitting it here. Let's suppose she split it here. This is the Alice first split, and Bob will throw away this part because this sum is more than this sum. Again, Alice will get this part for further splitting, right? Now, again, Alice will get again, she will split. Suppose she has now from here, she has two possibilities. She can split something like 6 to 3, or she can split something like 6 to 3, like this. I mean, here and here. So, again, suppose Alice split at here 6 to 3. So, again, Bob will throw away this part and again will give Alice something like this. Again, Alice will split this. So again, Alice will get something like 2. So isn't it something like recursive call we are doing here? Again and again, we are dividing it into smaller parts, right? First, if we draw the recursion tree, something for that like this, 6, 2, 3. 4, 5, 5. So she has multiple options to divide the this part. I mean, for example, if we say she can divide here 6, and first part will be 6 and 2, 3, 4, 5, 5. In the next part, she can divide something like this 6, 2, and 3, 4, 5, 5. Another part which she can divide 6, 2, 3, and 4, 5, 5. Like, and like there will be another branch also, something like this here for this part. Now, Bob will calculate the sum. This part sum is 6, this part sum will be 2, 3, 5, 4. 2, 3, 5, 4, 9, 5, 14, 19. This sum will be 19 and this sum will be 6. So Bob will take away the large part, it will throw it away, and further Alice will be given the smaller part. Here also, if we see, this part will be smaller. So again, further Alice will be given this, and this part will be thrown away. If you see here, again, Alice will be given this part for further, and this part will be thrown away, discarded. Now again Alice will divide, and it has written if like this the game will continue if there is only one store remaining. So here we can see only one store remaining, so the game will end here. Now Alice can further subdivide it. Again Alice will divide, so she can only divide, only one possibility will be something like this 6, 2, right? Here she can again this, she can divide, one possibility will be like this, another possibility will be something she can take, and like this, right? Again the same thing for here. Bob will take the large part, throw it away, and again will give Alice this part. Here also if we see, the Bob will take this part, throw it away, and will give Alice this part. Here also if you see, this part will be given to Alice. right? So if we see here if we see further, like we can see we are splitting at each possible point, right? This is what we are doing. 4, 5 and 5. So we are splitting it here. We are again splitting here. We are again and again and again, right? 6, 2, 3, 4, 5 and 5. And also parallelly we are calculating the sum of the sum of Alice. For example, let's say if we split it here, this part, so we will calculate the sum of this part and this part. Now suppose we take this point as k. So for the next game, I mean for the next iteration for like Alice, and suppose we mark this as L and we mark this as R. For the next iteration, what we are given to Alice, right? So if we can calculate the sum of from here to here, and we can calculate the sum from here to here. For example, the sum of this is left and sum of this part is right. So what is happening? For example, if left sum is greater than right, then Alice will take the right part, right? Because Bob is discarding the left part. So Alice will get something from k plus 1 to R for his next game to play. And if our left is smaller than right, then Alice will get something from L to K, right? And if both are equal, left and right both are equal. Now if both left sum and right sum are equal, then here in the game, like in the question given, then Bob let Alice decide which row will be thrown away, right? And Alice won the maximum score from here. So obviously she will like pick the side from where she can get the max, right? So she will pick to what? She will calculate the max what she can get from both. I mean from L to K, this is one side, like this is one side, and from K plus 1 to R, right? So if we see here 3 4 6 2 double 6 2 3 4 double 5. So if we see here 6 2 3 4 double 5, what we are actually doing, we are just splitting at different points, right? We are splitting it here, we are splitting it here, we are splitting it here, we are trying different points, right? So if we take like if we take this as K, we can start from here and we can start like splitting. If K is equal to 0, then we will split this and this. So this part will be again from K plus 1 and this part will be R, and suppose this is L. Suppose now K move here, right? So again we will split here and here, right? So we are splitting at different point, right? So if we like the recursion tree for this, suppose 6 2 3 4 double 5, it will be something like, for example, this. Suppose we split it here, like at the first point. So the sum, so Alice will get 6 because she will get the less sum, and for the rest of its operation, she will like also get the 6, right? If we split here at 6 2, Then the sum obtained by Alice is 8, and for the next iteration of the game, she will get 6 comma 2. If we split here, so she will get 4 5 9 5 14. Like here, from here, if we like split it here, the sum will be 4 5 9 5 14, and here it will be 2 3 5 6 11. So obviously she will get the smaller part and the smallest sum, right? So this is the small sum, and the smallest part obviously it will be 6 2 3. And if suppose we split it here, then the sum, like this part sum will be 10, which is obviously less than this part. So she will get 10 for its sum, and for the next iteration she will get 5 comma 5. Again there is a one possible splitting here, this is the last, so she will get 5, and for the rest of her iteration she will get this 5. So again, like she will perform the same. Let's suppose we take this branch. So what it will be, it will be like already she has like 11 points. Again she will split here, one possibility will be here. So 2 3 5 6, obviously she will get the smaller part, so this part sum is 5, this is 5, right? And this part is 6, so 11 plus 5. And also she will get for the next iteration 2 comma 3. If she will split it here, then from previous plus 11, and plus from here she will get 3, and for the next iteration she will get 3. Again if we branch it further down, this only, so from previous she has 16, again she can split it here only, this is the, so she will get plus 2, and also 2 is remaining for her for the rest of her, like this. So here we can see that what we are doing, basically we are 6 2 3 4 double 5, we are splitting at each possible point. First we are splitting at each possible point, we are calculating the sum of both the part, calculating both left and right part sum. Third, we are comparing both, we are comparing both left and right half and right sum. And after comparing, we got three choices. First choice is if left sum is greater than right sum, it is greater than right, then then Alice will get the right part. And plus, like she will also get the right subarray. Right subarray she will get for her next iteration. And if again, if left is smaller than right, then she will get the left sum, and for the rest of her iteration she will get the left subarray. And if both are equal, left is equal to right, then she can choose either left or right for her sum, plus she will choose from which of the like subarray like she will get maximum, right? Because like obviously like she need to maximize her score, so she will choose from left subarray or from right subarray, which is maximum, right? So this will be our logic for this problem, right? Now, now let's take this example with index this time 6 2 3 4 5 5, and here 0 1 2 3 4 5. Suppose we split it now. So during the first split, as we told, we will get from now we are tracking through index. So during the first split, it will be like 0 to 0, and from this part to this part, so it will be 1 to 5, right? One split is here is possible. Another split that is possible is from here to here, and that and there will be 2 to 5. This is one split. Again, this is another one, 0 to 2 and 3 to 5. And if we go down here, 0 to 3, and this is 4 to 5. I mean, there will be one more, but that is not needed. Let branch this one 0 to 1. So if we see from 0 to 1, sum is 8, right? 6 to 8 and 2 to 5. Obviously, the sum will be greater. So for the next iteration, Alice will get something like 0 to 1, right? And let's branch this out also. If we see from 0 to 2, the sum will be 6 to 8, 3, 11, and this sum 0 to 2, 6 to 8, 3, 11, and 3 to 5, the sum is 14. So obviously this one Alice will get for the next iteration. Again, we will branch out this further. So now we have choices. We can branch something like 0 to 0, and another will be 1 to 2, right? Another branch will be something like 0 to 1, and it will be something like 2 to 2, right? So we are seeing here this state and this state are equal, right? We are reaching the same state from this path also. If we take this path, and again we are reaching the same state if we are taking this path, right? Right. So from two paths we are reaching the same state. So why we need to recalculate this? Like obviously the answer from here and what we get from like from this path will be always equal. So we will cache this answer or memoization or DP for this part, right? 1 6 2 3 4 5 5. So if we see here 6 2 3 4 5 5. Suppose we split it here. K is here. This is L. This is R. Obviously, we need to calculate the sum of this part. Calculate the sum. Use something like prefix sum to calculate the sum, right? Because see, there are multiple indexes possible. K can be here. K can be here. So it is not very optimal for each time to calculate the sum. Right, so we can use something like prefix sum here. If we see, since every time calculating the sum for each k is not very optimal, right? Because see, k can be here also, we can split it here, we can split it here also, we can split it here. So every time we need to calculate the sum of both the part, we need to we need to redo this operation again and again for each k. So which is not very optimal. So instead we will use something like prefix sum to calculate the sum, right? So this is of length 6 and this will be of length 7. So 0 6 2 8 3 11 4 15. This will be 20 and this will be 25. right? So, suppose we are here k, so we need to find the sum of this part from here to here. So how we can find out? We can find out just simply like, uh, for example, this is a prefix array with name prefix. So we can simply calculate for k. It will be something like prefix of k plus 1 minus prefix of L, right? Because we are calculating from here to here. And if we want to calculate from here to here, so it will be like from r plus 1 to minus prefix, since this is k, so this is k plus 1, so k plus 1, right? So this will give our left sum for each k, and this will give our right sum for each k. Now since we have calculated the way to calculate our left sum and right sum, now we can write the whole algo. As we have discussed, we are like splitting at every point. Let's suppose 3, 4, 5, 5, something was there. So this is L, this is R, and we are splitting at each point, right? So what we will do, we will write one for loop for splitting. So loop will go from int k equal to L, k is less than R, and k plus plus, right? See, because we can't split it here, we need to stop here at each point, right? We can't do something like this. I mean, Alice can't choose all this. She need to stop here. And with our formula, we will calculate the left sum. So the left sum will be prefix of k plus 1 minus prefix of L. Suppose she split it here, k will be here. So k plus 1 minus pref of L, and the right sum will be r plus 1 to pref of k plus 1, right? Now obviously like Alice will take the min of both, right? So the score by Alice will be, we can calculate the score of Alice here. What she will get from this partition, she will get the min of both left sum and right sum. And for her next iteration, she has three choices. Like as we have discussed, one choice is if left sum is greater than right sum, then Bob will take the left sum. I mean, Bob will discard the left sum, and Alice score will be something like score of Alice that we have just calculated. Plus, she will get the left. I mean, she will get the right subarray for her next iteration. So right subarray will be from k plus 1 to r, right? And if our left sum is smaller than right sum, then obviously the score will be score of Alice. Plus now she will get the left subarray. So left subarray will be from L to K, right? And if both are equal, in that case, if left sum is equal to the right sum, in that case, she can choose either score, and obviously like she wants to maximize her score, right? So she will choose what she will get from both left and right. So from both, from L to K, from left subarray and from right subarray, what she will get? She will choose both for her score. And since we are splitting, we are splitting at different like points, so there will be multiple possibilities, and we need to find the max of all those possibilities. So for each splitting, like there can be multiple option. So we will have one max here, and we will find all the max of all such possibilities, because see here k can changing, right? What we are doing, we are like splitting from L to R at each point. So k can be 1, k can be 2, k can be 3. Each splitting is creating a new path for us, and from each path we need to find the max sum, right? So we will find the max of all such paths for all k, and we will get our answer. Similarly for here also, max, and similarly for here also, max will be score plus Alice plus max of from all such paths. So let's get back to the code part of it. So if you see here, we are calculating the prefix sum, and we are using one prefix subarray to store the prefix sum. So we need to recalculate it again and again. And we are writing one like recursive code. Here they have given, if L equal to R, for example, one eval store remaining, like then obviously we can't choose anything, right? Like, so the sum what she will return is 0. And now from here we will split for each at each point from L to R. We will calculate the left sum, we will calculate the right sum. Obviously Alice will get the min of both. And now our three choices. If sum left is greater than sum right, then Alice will get the right subarray for her iteration. So from here, if you see score gained by Alice plus solve, this is for right subarray k plus 1 to R. And if left sum is less than the right sum, then she will get the left subarray. So score again plus n from L to k, the left subarray. And if both left and right are equal, then she can choose from any of the left subarray or right subarray. But obviously she will choose the max, right? Because she need to maximize her score. So she will try both the possibilities from from the left subarray and from the right subarray, and from like whatever she will get the maximum, she will add, and at the end we will store it in our like DP, and we will like return our answer for this part.